Hello everyone, very good evening. I welcome you all at India's most comprehensive preparation platform for all competitive exams, that is BYJU'S Exam Prep. So guys, very good evening again. In this session, we are going to discuss that how do we check the relationship between two given FD sets. That will be the topic of today's discussion. This is a brief introduction of myself. My name is Vishal Rawatiya. I have 10 plus years of teaching experience. These are the achievements and areas of expertise. Okay, so guys, there is a very good announcement for all of you. On 25th of June, that is on Sunday at 9 a.m., BYJU'S Exam Prep is going to conduct a national scholarship test for all GATE aspirants. So do participate in this particular test and you may avail up to 90% of off on all our programs. Okay, so let's start with the today's session. Very good evening, GATE CSE, GATE EASE CSE. So let's start with the session. So what does it say? So first, before we understand the concept of relationship between two FD set, we need to understand the concept of membership test, because the concept of relationship between two FD set is basically dependent on this membership test. So what do I mean by membership test? Membership test is used to check whether a given FD is a member of a given FD set or not. So two things will be given to you. One will be an FD set, another will be a different FD, and they will eventually ask whether the FD is a member of that FD set or not. So to check, so let's try to understand. To check whether X implies Y, there is a given FD is a member of the FD set F or not. But this can be any FD set F. So how do we denote this? Whether F, this FD set F, yields the FD X implies Y or not. What does it mean? Whenever this FDs of FD set F are true, whether this FD X implies Y is true or not. So to check this is a very simple concept. You are actually looking whether X implies Y is a member of this FD set of F or not. So you just need to check whether X can derive this attribute set Y or not with respect to this FD set F. So what you need to calculate? You need to calculate the closure of this X with respect to what? There is a given FD. You cannot find the closure with respect to X implies Y itself. So you need to find the closure of X with respect to FD set F. So the very first thing which you need to do is obtain the closure of X with respect to FD set F. So once you have obtained the closure, you just need to check whether Y belongs to that FD set, Y belongs to that closure of X or not. So that's only you need to check. So if Y belong to the closure of X means with respect to F you find the closure of X, then you can determine Y. That means Y can be determined by X with respect to FD set F. That's what the closure gives, the set of all attributes which can be determined by the given attribute set. So if Y belongs to closure of X, then X implies Y is a member of the FD set F, otherwise not a member of FD set F. Simple concept. So let's try to understand this with respect to an example. So let's say that let FD set is this, A implies B and B implies C. Check whether A implies C is a member of this FD set F or not. So if you know the rule of transitivity, you directly know that A implies B and B implies C. Therefore, by transitivity, A implies C. But let's check. So what you need to do to check A implies C. So this is your X and this is your Y, right? To check whether X implies Y is a member of FD set F or not, what you need to do? You need to calculate the closure of X. That is, we need to identify the closure of A. But with respect to what? With respect to F. With respect to F. So what all can be determined by A in FD set F? So A can obviously determine A. Now from A you can determine B. From A and B you can determine C. So all these things can be determined by A in the FD set F. Now you just need to check whether Y belong to, Y is C, Y belong to this A closure or not. So you can actually see that C belongs to A, B, C, right? C belongs to A, B, C. Therefore, A implies C is a member of F. Simple concept. Now what does it mean? The FD may not be given directly in the FD set F, but there are some FDs which are implied by the FDs which are present in the FD set F. So that's what we are trying to check, whether they are member or not. So let's try to solve the next example. Check this. Let FD set F is nothing but AB implies C. This is one FD, another is BC implies D. Now you are being asked to check whether AB implies D is a member of F or not. So here this AB becomes your X and this D becomes your Y. So tell me whether AB implies D is a member of this FD set F or not. Reply fast. Reply whether AB implies D is a member of this FD set F or not. Guys, do participate in the discussion. It will be more helpful. It will keep you engaged. It will not let you get bored during the class, because if you only try to watch something, then perhaps you know most of the things, and in that case you will eventually get bored during the session. Yes, so what we need to check? We need to check the closure of X. So X is basically what? X closure basically means AB closure. So what is the AB closure with respect to F? AB closure with respect to F will be, first of all, you will add A and B itself in the closure. Now from A and B you can determine C, therefore you will add C. Now from B and C, so what's actually happening? From AB you can determine C, and from BC you can determine D. So that's it, my task is done. D actually belong to the AB closure. Yes, therefore AB implies D is a member. One last example, try this. One last example, try this. Fatafat. Don't waste your time. You don't even need to write those many things. I'm just explaining, therefore I'm writing. Otherwise, what you need to do? Just check for the C closure. C, can I get anything? C closure will be CA. Can I get anything from CA? No. So, what will be C closure? C closure will be C. And from C, you can determine A. Can you determine anything else from A and C? No, sir. So, this is the idea. So, your B does not belong to C closure. Your B does not belong to C closure. Therefore, C implies B is not implied. This is a new term, implied by. So if it is a member, then we will say, okay, that the FD is implied by the given FD set. If it is not a member, then we will say not implied by the given FD set. Is not implied by F. Got the idea? Simple story. So now you know what do I mean by membership test. Now how do we use this concept of membership to check the relationship between two different FD sets? Now come to the relationship between two FD sets. Let's assume F and G are any two FD sets. We don't know what are the FDs of F and G. But if at all you want to check the relationship, then either, so let's look at the definition. It will be more easier, because either FDs of F will be involved in the G, FDs of G will be implied by F, or they both will be equal. So what are the things? If all the FDs, so what am I saying? Two sets, F and G. If all the FDs, whatever FDs are there in the FD set F, if they are also member of FD set G, then can you say that all the FDs of F are member of G, therefore F has to be a subset of G? That the FD set F has to be a subset of G. So if all the FDs of FD set F are member of FD set G, then we can say that F does not contain any FD which is not a part of G. Therefore, if all the elements of F are contained inside G, therefore F is a subset of G. Right? So we can say F is a subset or equals to G. Means all the FDs of F are involved in G. G contains all the FDs of F, so at least equal, but it may contain some other FDs as well. Right? Now the second is, so that's between F and G, one relationship. If all the FDs of FD set G, now we are talking in the reverse direction. If all the FDs of FD set G are member of FD set F, then we can say that G is a subset or equals to F. G is a subset or equals to F. Now tell me, when do we say two sets are equal? If A is a subset or equals to B and B is a subset or equals to A, then A equals to B. Otherwise, it is not possible. Both the things can be true only if A is equals to B. So, if both F is a subset of G and G is a subset of F are true, then we say that both of them are equal. Then we say both of them are equal. If any one of these two is not satisfied, then we'll say F is not equals to G. Got the idea? F is not equals to G. So let's try to understand. It will be more meaningful if you look with the help of example. So consider the following FD sets. One is FD set F1, another is FD set F2. Now I am asking, find the relationship between FD sets F1 and F2. So first check if F1 is a subset or equals to F2 or not. So what we need to do to check this? To check this, you need to see whether FDs of F1 are member of F2 or not. So that is, check FDs of F1 are member of F2 or not. So what we need to do? We need to check one by one. So first FD is A implies B. So to check whether A implies B is a member or not, you will check A closure, but this closure will not be with respect to F1. You need to check whether this A implies B is present in this or not. So we can directly see that A implies B is preserved. So A closure, when you calculate A closure with respect to F2, that's the complete process. Otherwise, some FDs are directly visible. Got the idea? So this too has to be seen. So A closure will be what? A closure will be A. From there, you will calculate B. From B, you will calculate C. And from A, you can also obtain D. Therefore, this will be the set of A closure with respect to, so this is with respect to F2, right? So do you see that B, what do we check? We see that B is a member of A closure, therefore member, right? Let's check for the second FD. So B implies C. So again, I can directly say, but you can actually see that directly present, directly available in F2. So FDs which are directly available, for them, you don't need to find the closure. But for the first one I have explained, directly available in F2, therefore member. Yeah, obviously that's what we are trying to see, whether B implies C is a member or not. We can directly see with our bare eyes that B implies C is a member. We don't need to do any calculation, right? What about third? Third one is AB implies G. Third one is AB implies G. So some of the things will be directly clear. If A closure itself contains D, then AB closure will eventually contain D. If A closure itself contains D, then AB closure will eventually contain D. But for your happiness, I can calculate AB closure. AB closure is what? A, B. Because of B, you can calculate C, and because of A, you can calculate D. So you can actually see that D belongs to AB closure, therefore member. Now can you see all the FDs of F1 are member of F2, right? So all FDs of F1 are member of F2. So what can we say? Therefore, one thing is sure that F1 is a subset or equals to F2. Let me call it equation 1. That okay, we have obtained one type of relationship, that F1 is a subset of F2. Clear? Now, let's move to check whether F2 is a member of F1 or not. So this is the same example which is being continued on the same page. So check F2 is a superset, or sorry, F2 is a subset of F1 or not. So this time you will have the FDs of F2. How can you do that? FDs of F2. Here you will have closure with respect to F1 and comment. So that's the normal procedure if you want to do. This 3 column and you are done. So the first FD is A implies B. So you will try to directly available. So B implies C is directly available. A implies C, that's what we need to check. A implies C is a FD and F2 which is not directly available in F1, therefore find A closer. So when you obtain A closer with respect to F1, A closer will be A, B, and from B you can calculate C, and from AB you can calculate D. So we can actually see that C belongs to A closer, therefore member. C belongs to A closer, therefore member. And apart from that, A implies D. A implies D. That's also not directly available, therefore. But A closer is already calculated. So you can see for all the FDs for which this determinant is same, you don't need to calculate the closer separately. You can comment about all those FDs by calculating the closer only once. So you can also see that the D also belong to A closer. D also belong to A closer. So you can actually see all the FDs of F2 are also member of F1, right? So what can we say at this point of time? So all FDs of F2 are member of F1. Therefore, what can we say? F2 is a subset or equals to F1. This is equation 2. Now, what did we say? If F1 is subset or equals to F2 and F2 is subset or equals to F1, then by equation 1 and 2, we can say F1 is equals to F2. So this is the relationship between these two FD sets. Hi sir, what is this sir? What is this sir? And Ashrita Lakshmi, this is the concept of database management system. If you are from computer science background, then you must know this, and if you are not from computer science background, then perhaps you are at the wrong place. So first tell me what is your branch, then we can discuss further, right? So this is it. This is, now let's try the next question. Give me the relationship between F1 and F2. Please give me the relationship between F1 and F2. Check whether F1, what is the relationship between F1 and F2. So we are not going to waste a lot of time. You can actually see, sir, A implies B is present in both the FDs, therefore we don't need to check. B implies C is present in both the FD sets, therefore we don't need to check. We only need to check F1 is a subset of F2 or not. Call out my name. This is not a shout out video. It's not. F1 is a subset of F2 or not. Beta, please let us conduct a class. Okay, so what we need to check? We need to check A implies C. So FD is A implies C. What do you need to check? A closer with respect to F2 will be what? A closer with respect to F2 will be A, obviously B, from B C, and from A you can determine D, right? So C belongs to A closer, therefore member. Therefore A implies C is a member, right? So what can we say? Therefore F1 is a subset or equals to F2, because 2 are directly available. For the third one we have checked that this is also a member of F2. So F1 is a subset or equals to F2. This is the first equation. Let's move to the second one. What happened? In the second one, we have already seen that this is a FD, a member of F2, this is also a member of F2, this is also a member of F2, this is a member of F1, this is a member of F1. Now check that F2 is a subset of F1 or not, right? So what we need to check? Sir, the FD which we are looking for is A implies G. So you need to check the closure of A with respect to F1. Closure of A with respect to F1. What will be closure of A with respect to F1? Sir, from A you can determine A, from A you can determine B, and from B you can determine C. So these are the only things. The D is not at all being determined by any of the attribute in FD set F1. Therefore, this will be the closure of A with respect to F1. Now you can see that D does not belongs to A closure, right? Therefore, A implies D is not a member. Now let's try to understand. What does it mean? That is, F2 is not a subset of F1, right? This is your equation 2. What can we say by equation 1 and 2? By equation 1 and 2, we know one thing, that all the FDs of F1 are present in F2. All the FDs of F1 are present in F2, but there are some FDs into F2 which are not present in F1. Therefore, can we say that F1 is a proper subset of F2? This time, this equality symbol will not exist because F1 is a proper subset of F2. Yes or no? Got the idea? Arey N Ashrita Lakshmi, Jai Ho. I have called out for your name, Jai N Ashrita Lakshmi. Now let us focus, please. Right? So that's what. So from equation 1 and 2, we can say F1 will be a proper subset, not even equal, not even equal. Got the idea? So these are the relationships which will be available in the option, and you need to choose the best option. If it is a MSQ, then this F1 is subset or equals to F2 will be true, as well as F1 is a proper subset of F2 will also be true, because both of them are true. Clear? So just make sure that you choose the best possible option. Let's check for the third one. What I would say, give me the relationship between F1 and F2. Give me the relationship between F1 and F2. Are they equal, or whether F1 is a proper subset of F2 or F2 is a proper subset of F1. So three things are possible. What are the three options possible? Either F1 will be equals to F2, or second will be F1 will be proper subset of F2, or third, F2 is a proper subset of F1, fourth, F1 is not a proper subset of F2, fifth, F2 is not a proper subset of F1. So when you say not, then if both of them are of the type in which some of the FDs of F1 are not in F2 and some of the FDs of F2 are not in F1, then both of them will be true. Both of them will be true. Clear? So let's try to understand. Check. F1 is a subset of F2 or not. So these are the possible things which you can answer based on the calculation done. So first one is A implies B. First one is A implies B. Right? So what is A closure with respect to F2? A closure with respect to F2 is A, B, C. Now you can actually see B is a member of A closure, therefore member. See, I should not write this again and again. Second is AB implies C. So if A closure itself contains C, therefore AB closure will definitely contain C. So you can actually say, I'm directly writing C belongs to AB closure. So that's what I said. If you use some mind, you will not have to calculate all the closures. So C belongs to AB closure, therefore member. Right? Third one. See, you can actually see, sir, here D implies AC and D implies AE. Both of them are having the same determinant. Therefore, you can check for D implies AC and D implies E direct with a single closure. So what you need to calculate, sir? D closure with respect to F2 will be what? D closure with respect to F2 will be D2AE. D2A and E. You can actually see that from A in F2 you can also determine B and C. From A in F2 you can also determine A and C. So what can we say? Sir, what do we observe? That A and C both belongs to D closure. A comma C belong to D closure, as well as E belong to D closure. Therefore, both are member. At this point of time, hence, if all the FDs of F1 are member of F2, therefore we can say F1 is a subset or equals to F2. This is your equation 1. Done. This is your equation 1. Correct it. Right? Now, let's check whether F2 is a subset of F1 or not. So, check F2 is a subset of F1 or not. So, the first FD is A implies BC. So, what is A closure? This time you will calculate the closure with respect to F1. A closure with respect to F1 will be what? F1, A closure. A, from A you can determine B, from AB you can determine C, nothing else can be determined. Fine, good enough. Right. So, B and C both are member. B and C both are member. So, B and C both belong to A closure. B and C both belong to A closure, therefore member. This first. Second FD is D implies AE. Right. So, what will be D closure with respect to F1? D closure with respect to F1 will be obviously D. Now, from here, from D you can calculate A and C. From D you can also calculate E in F1, and from A in F1 you can determine B. So, all the attributes are determined. So, what can we say? That okay, A as well as E are member of D closure, therefore member. So, both the FDs of F2 are member of F1, therefore F2 is also a subset of F1. This is equation 2 by 1 and 2. By 1 and 2, F1 is equals to F2. So, these are the ideas. This is how you can calculate the relationship between two FD sets. Clear, everybody? Clear. This is how you can calculate the relationship between two FD sets. So, one concept is to check whether a given FD is a member of given FD set or not. Another is to check whether if given two FD sets, what is the relationship between them? Either one will be proper subset of another, or second will be proper subset of first one, or both these statements will be true. In that case, both will be equal, or none of those two statements will be true. So that's all. That's okay, clear, right? Now, one more thing which can be done with the help of this membership test is what? So, FD set, you can also calculate FD set of a subrelation. FD set of a subrelation of a given relation. So, there is a given relation and somebody is asking to define the FD set of a subrelation of that given relation, then you can also do that. So that's what I'm just saying. We can use the concept of membership to obtain FD set of a subrelation of a given relation R with FD set F. So what you should know, you should have a, you should be knowing the relation and you should be knowing the FD set of that given relation. Then you can calculate the FD set of any subrelation of that given relation with respect to the given FD set F of the given relation. So let's check. Let's try to understand this with the help of example. What is this? Consider a relational schema A, B, C, D, E. So this is a relational schema A, B, C, D, E with FD set F. So this is the given relational schema and this is the FD set of given relational schema. This is it. This end is not there, because I have just used the same question to derive a new question. Find the FD set F1 for subrelation R1. So let's assume if this R1 is a subrelation which is derived from the relation R itself, if this subrelation R1 of relation R which consists of 5 attributes. So what does it mean? That let's assume that there is a relation R which consists of 5 attributes. So out of those we are projecting only 3 attributes A, B and E. Then that will become a subrelation for that relation R. Now what are the functional dependencies which will exist in this subrelation R1? That's what we are trying to find out. So how can we do that? How can we do that? So obviously you just need to understand one thing, that trivial FDs will always be implied in any relation. So if you look at the, so for relation R1, for relation R1 A, B, E, possible non-trivial FDs are so we have already discussed this concept that if you are trying to find out that what are the possible non-trivial FDs in a relation, then you will eventually write all the possible non-trivial FDs and then you will check that which of those FDs are valid. So possible non-trivial FDs are, what are the non-trivial FDs which are possible? You can say A implies B, A implies E, then you will see B implies A, B implies E, and you will say E implies A, E implies B, right? These are the possible. Apart from this 6, the FDs which are possible are A, B to E, right? A, E to B and B, E to A. I have already told you that you don't need to worry about FDs A implies B, E. A implies BE, B implies AE and E implies AB. Why you don't need to worry about this FDs? Because if both A implies B and A implies E are present, then you don't need to write this FD. This is just a redundant FD. Even if you don't write it, you know that from A we can determine B as well as E. Therefore, you don't need to write it explicitly. Got the idea? So you don't need to check for this FDs whether A implies BE or B implies AE or E implies AB are present in this subrelation or not. So that's the idea. What happened now? Sir, now we have identified Now we have identified some of the, now we have identified all the non-trivial FDs which may be present in the relation R1. Now you need to check that which of this following FDs may be true in this or may hold true in this relation R1 with respect to this FD set F. So what you need to check? You need to check the closure of A with respect to F. So what is the closure of A? What is closure of A? Tell me. What is A closure with respect to F? Sir, A closure with respect to F will be A. A can be determined. B can be determined. From B you can determine C. C. And you can determine E only from E. You can determine E only from E. Yes or no? This will be the closure of A. This will be the closure of A. So B belongs to closure of A with respect to FD set F. Therefore, A implies B is implied in FD set F. But E does not belong to, sorry, erase re bhai. What do we say? B belongs to A closure. Therefore, this is present. Here, E does not belong to A closure. Therefore, this FD is not a valid FD. Right? Now, what do we need to calculate? We need to calculate B closure with respect to F. What is B closure with respect to F? B does not determine anything in FD set F. B does not determine anything in FD set F. Therefore, B closure with respect to F will be B only. Therefore, you can actually say A does not belongs to B closure. Therefore, B implies A is not present in the relation, and E also does not belongs to B closure. Therefore, this B implies E also not present in the relation. Similarly, what is E closure? Sir, E closure with respect to F will be E only. Nothing can be derived from E. Nothing can be derived from E. So what will happen? A does not belongs to E closure. Therefore, this FD is not present. Similarly, B also does not belong to E closure. Therefore, this FD is also not present. Now we need to check for AB. So we'll see whether AB closure, what is AB closure with respect to F. So AB closure will be ABC. AB closure will also be ABC, right? So AB closure is ABC. So you can actually say that E does not belong to AB closure. Therefore, this is not a valid FD in this subrelation ABE. Similarly, you will calculate AE closure. So what is AE closure with respect to F? AE closure is actually A. From A you can determine B, from AB you can determine C, and from E you can determine E. You cannot determine D by any attribute. Therefore, you can actually see, can we determine B from AE? Yes sir, B belongs to AE closure. Now you will understand one thing. B belongs to AE closure. Therefore, this is a valid FD. But you just need to understand that if A alone can determine B, then AE determining B will be a redundant thing. But anyway, this is a valid FD. Anyway, this is a valid FD. Last one is BE closure with respect to F. So what will be BE closure? Sir, B does not determine anything. E does not determine anything. Therefore, A does not belongs to BE closure. So I have just given an example that what you can do. So you can eventually see that by doing this, you can eventually calculate by doing this that given a subrelation, you will first try to obtain that what are the possible non-trivial FDs, those may be present in that subrelation. Now you will check that what among those possible non-trivial FDs are implied by the original FD set F all the non-trivial, all possible non-trivial FDs which are implied by original FD set F will be the member of the FD set of relation R1. So what can we say? Therefore, F1, that is FD set with respect to R1, FD set with respect to R1 is nothing but it will consist of two FDs. What are they? It will consist of A implies B and AE implies B. So these are the only two FDs. Now, so what is the importance of this? So the importance of this is that you can you actually see that I have decomposed this relation R. Let's assume if I decompose this relation R into sub-relations such that R1 consists of some attributes, let's say A, B and E, and there's another relation R2 which consists of some other attributes, for simplicity A, B, C, D. Let's assume this is the idea that A, B, C, D is present there and this is present here. I am not talking about the lossless or dependency preserving at this point of time, but what's the idea? If you decompose, I have already told you in the yesterday's class that the normalization is nothing but the process of decomposing a relation into sub-relations so that the redundancy is removed or reduced, right? So you will eventually try to decompose the given relation into sub-relation. Now, when you are decomposing the relation into sub-relation, you will have to check whether all the FDs of the original relation are preserved using this decomposition or not. So you will have to check that what are the FDs which are preserved in R1, what are the FDs which are present in R2. Then you will have to check whether in the union of the FD set of R1 and the FD set of R2, all the FDs of original relation R are preserved or not. If preserved, then it will be dependency preserving decomposition. If not preserved, then it will not be a dependency preserving decomposition. Therefore, this concept which I have explained at the end is very important. This concept which I have explained at the end is very important. You must understand this thing, that this thing will be used to check the FD set of these sub-relations, and based on that only we will define whether the decomposition of a given relation into sub-relation is a dependency preserving decomposition or not, which is a very favorite question of GATE organizing institutes, right? So this is the idea. So I hope you have understood everything, that what is the use of membership test. So membership test, as one uses to directly check whether a given FD is a member of given FD set or not, then to check whether what is the relationship that holds between two different FD sets, and another is that if you have a relation and if you try to provide the FD sets of the sub-relation, then you can use that particular thing. Now let's try to understand one more thing. You cannot define the candidate key of this sub-relation without the FDs of this sub-relation. So though you have the relation R and the FD set F, then you may define the candidate key of the relation R with respect to this FD set F, but you cannot define the candidate key of relation R1 with the FD set of original relation R. To define the candidate key of this sub-relation R1, you will have to identify the FD sets of this sub-relation R1, and from this FD set we can directly say that the candidate key of R1 is AE. AE together can determine all the attributes of this relation. A alone cannot determine. A is not capable of determining E, and B cannot determine anything else. Only AE can determine all the attributes of this sub-relation R1, and therefore AE will be the candidate key of this relation R1. Whereas, what is the candidate key of relation R? What is the candidate key of relation R? Sir. candidate key of relation R is A can determine A, B, C, and you also want to determine E, therefore you can have D. So D is not in the right hand side part, A is not in the right hand side part, A is in the right hand side part. So yes, fine, that's okay. That no, you don't need this. You don't need this. D is A. 1 second. Yes. So what is the candidate key of this relation? D closer will be D. D closer will be D. From D you can determine A, C, E, and from A you can determine B. Therefore, D is the candidate key. What is the candidate key of relation R? Candidate key of relation R is D. Candidate key of relation R is D, whereas the candidate key of this subrelation R1 is AA. So don't think that whatever is the candidate key of relation, whatever is the candidate key of original relation will also be the candidate key of subrelation. No, not necessary. Don't make any conclusion by yourself. You just need to check everything. Got the idea? Is this clear to everybody? Please clarify. Is this clear to everybody? Okay, guys. So this is it for the today's session. Now there's a very important announcement for all of you. Now, as you all know that I'll get a very limited time on YouTube. Therefore, to complete one more topic of one more topic of database management system, I am coming with BPL series. In that particular BPL series, I will cover what? I will cover relational algebra, I will cover SQL, and I will cover TRC. These are the three most important things of database management system, because every year at least one question of 2 mark will be asked from one of these three topics. Right. So what will happen? This session will be conducted on 24th, 25th and 26th of June. This session will start at YouTube. This sessions will start at YouTube at 9:15 p.m. Sessions will start at YouTube at 9:15 p.m. At YouTube, I will discuss the concepts related to this topics. Tomorrow, I'll discuss the concept of relational algebra. Then on Sunday, I'll discuss the concept of SQL. On Monday, I'll discuss the concept of TRC on YouTube at 9:15, and then at app at 10:15 p.m. So for 1 hour, I'll discuss the concept, and after the discussion of those concepts at app from 10:15 p.m., I will discuss the questions related to those concept, right? So most probably I'll include the questions from GATE itself, so that you will have the intuition that yes, whatever we have discussed during this YouTube session are sufficient to solve the questions of GATE. Clear? So please mark your calendar from tomorrow on from 8 p.m. to 11:15, because at 8 p.m. we will be having the sessions of normalization. From 9:15 I'll start this queries languages, and at 10:15 we'll solve the questions of query languages for at least 1 hour. So I'm just asking you 3 days, right? So that you can get sufficient marks in the database management system subject in the GATE 2023. So please give me 3 days from 8 to 11:15, and you will be done with 2 most important topics of database management system. By the 26th or 27th, we will be done with the concept of normalization, as well as we will be done with the concept of query languages. Now, why tomorrow's session is very much important for all of you? Because I will conduct the relational algebra classes in a separate session. In that particular relational algebra concept, I will discuss the concept of join. And that join is a very important thing when you try to understand the concept of normalization, because when we decompose a relation into sub-relation, we need to ensure that the decomposition is lossless join decomposition, and you will understand that only if you know the concept of join, and that concept of join will be discussed only in the relational algebra session. So please make sure these are two independent things. Don't think that one is combined with another. If you have not attended the sessions of normalization or functional dependency and normalization, then also you can attend the sessions of query languages, because those sessions will be completely independent, right? But some of the things discussed in those sessions may be used in this regular sessions of normalization. So please make sure that you manage your time accordingly. So which branch is, what is IN in engineering? Instrumentation, Dhruv, but this is CSE. Okay, so anyway, that will be all. Thank you very much. I hope you enjoyed this session. If you enjoyed this session, then please hit the like button. If you are new to the channel, then kindly subscribe to the channel and press the bell icon so that you can get the notification about our upcoming videos. That will be all for this session. Thank you very much. Good night. Take care.